Okay, here we are with an electronics question. I've got a prototype circuit here, LDR there, variable resistor here, safety resistor here, protecting the transistor, and a relay which is activated when the light intensity changes. It says, state the full name of an LDR. Well, component recognition, very important. Light dependent resistor. Okay. The variable resistor and the LDR form a voltage divider subsystem. Describe the operation of the voltage divider. Well, that's this part here. Okay, so you've got your voltage supply in. It's split between here and here. It's divided, and you get a V out here, which can turn on or off the transistor. So, what's the operation? Well, the words that we're going to use in our description would be LDR. It would also be variable resistor and voltage out. Right. First thing that it does, well, it's all due to the light intensity. So as the light intensity on the LDR increases, its resistance decreases. 1 mark. Okay. This raises the value of V out because less of the voltage is required to go through the LDR because it's got less resistance. Okay. Now, the variable resistor is used merely to set the threshold value of V out to trigger the transistor. So, the variable resistor sets threshold for V out to trigger transistor. Okay, what's next? It says determine with reference to the data booklet the resistance of the LDR. I've got the page here, and so what we need to do is find the light intensity of 300 lux. Well, if you look across the bottom, you've got 10 lux and you've got 100 lux. 10 to the power of 2 is 100. We're looking for 300, so that would be 200 and 300. We then go up to the line, and where it intersects with the line, go horizontally, and we get to here. Okay, so we can now see that this would be 1 kilo ohm, so that would be 700, 500, 400, 300, so it's 400 ohms. Okay, next it says calculate V out. Well, we need to know the formula for V out, and the formula is V out equals, well, let's look at these two now. The voltage dropped across the first one would be the voltage across the first resistor, so we'll call that R1 and we'll call that R2. If we now look at the formula, we've got R2 ratio with R1 plus R2 multiplied by VCC, the voltage supply, which in this case is 5 volts. So that is equal to 1500 ohms divided by 1900 ohms multiplied by 5 volts. Onto the calculator. 1500 divided by 1900 times 5 equals 3.95 volts. Second part of the question now. Complete the circuit diagram to show how the diode could be used to protect the transistor. Well, the EMF, which can damage semiconductor components, needs to be escaped at power down. So we put the diode in just there. State the name given to this condition when VBE is 0.7. Saturation. And it says, here's the symbol for the transistor. We've got the base and the emitter. Explain why relay is often used with electronic circuits. Well, the control side of the circuit is usually quite low powered, maybe 5 volts. So it allows a 5 volt control circuit to activate 240 or mains volt load circuit. Now this means that you can actually have quite large currents, so larger currents can be used to power the load. Okay. It then says a DPST, that's double pole single throw relay, is used in the circuit. State the names of these types of relays. Well, we've got a single pole with just a single throw. That's a SPST, single pole single throw. And here we've got a single pole double throw, SPDT, single pole double throw. State the name of the relay type which would allow forward and reverse motion. It's sometimes called the reversing switch, but we call it double pole double throw, DPDT, double pole double throw. That's that question.